All right, guys. So this is the second half of the 12-3 video. So if you haven't watched the first half, please look over that and take notes over that before you move on to this one. So we just have two more examples and then we'll be done with this. Okay. So let's look at example 4. It says a satellite TV provider surveys customers in 3 different cities. Clearly those cities are Glendale, Santa Monica, and Long Beach. So I'm guessing this is in California. The survey asks whether they would recommend the TV provider to a friend. The results were given as joint relative frequencies are shown in the two-way table. Okay, so here they are. What is the probability that a random selected customer located in Glendale will recommend the provider? All right, so let's do some totals here, okay? So let's just add up each of these columns. So 0.29 plus 0.05 is 0.34. 0.27 and 0.03 is 0.3. This is 0.36. Okay, those add up to 1, so we're good. So across, this would be 0.88, and this would be 0.12. Those add up to 1, so we're good. All right, that'll make our lives a little easier. So the question says, and remember, we have to read these really, really closely when we're dealing with statistics. What is the probability that a random selected customer who is located in Glendale? We don't worry about the entire population. We're just worried about the Glendale customers right now. Okay, will recommend the provider. Okay, so the probability that Glendale will recommend. Okay, so that'd be the total that said yes, they recommended it, equals 0.29 out of the entire Glenwell population, which is 0.39. Okay, so 0.29 divided by 0.39, that gives me, oh, that's a 3/4. Sorry, guys, that's a 4. I can't read my own writing. 3/4. Let's try that again. 0.29 divided by 0.34. That looks a little closer. That is roughly 0.85. Okay, or I could say about 85% of all Glendale residents surveyed would recommend. Okay, so let's look at part B now. Part B says, what is the probability that a random selected customer who will not recommend the provider? Okay, so now our total population is the ones who aren't recommending them. So this right here, okay, is located in Long Beach. Okay, of all of them who don't recommend it, are 0.04 is from Long Beach over all of them, which is 0.12. 0.04 divided by 0.12 is 0.33, or 33% of all the people who don't recommend come from Long Beach. All right, I want you to go ahead and try to figure out C on your own, and then we will look at it together. All right, so when I talk about recommending a provider and living in Long Beach, are those anywhere related? Like, does recommending a friend have anything to do with you choosing to live in Long Beach? No. So these would be independent events. All right, let's look at our last example. This is example 5. So it says a jogger wants to burn a certain number of calories during his workout. He maps out 3 possible jogging routes. Before each workout, he randomly selects a route and then determines the number of calories he burns and whether he reaches his goal. The table shows his finding. Which route should he use? Okay, so we want to know, when did he reach his goals? Okay, so the first thing I want to do is add up all these tally marks. Okay, I want to get the marginal frequencies. Okay, so here's 5, 6, 6 plus 4 is 10, 15, so there's a total of 16 there. 10, 11, and 11 is 22, 32, 33, 34, And here are, add those, it's 50. All right, now 5, 10, 15, 16, 17 is route A. He went 11, 15 down route B, and 18 on route C. If you add those up, they do equal 50. All right, so we want to look specifically at route A, route B, and route C, and we want to find the probability that when we ran that route, we achieved our goal. Okay, so we're going to look at route A, and then separately, we're going to look at route B, and then separately again, we're going to look at route C, and then we're going to find the probabilities of achieving a goal for each of those three, and then compare them. All right, so for route A, we reached our goal 11 out of the 17 times we ran it. Okay, route B, we reached our goal 11 out of the 15 times we ran it. And then route C, we reached our goal 12 out of the 18 times we ran it. Okay, so if I put these in my calculator, 11 over 17 is roughly 0.65, or 65% of the time we reached our goal. 11 over 15 is 0.73. 12 over 18 is 0.67. So we had the highest probability of reaching our goal when we ran route B. So therefore, I would recommend he run route B.